Okay, so this lecture here, this is lesson number 2, so week number 2 in ERT107, the Industrial Robotic Technologies and Workshop Practices course. This week we are going to be talking about risk assessment and risk reduction. So this is going to be a continuation of our hazards and risks talk from week 1. So now we're going to be talking about how to actually assess and reduce these risks. So we're going to do a little bit, I should say, oops, sorry here, that should say week 2. We're going to do a little bit of review from last week, go through some definitions, and then get into assessment and reduction. So a hazard, a physical source of potential damage, harm, or adverse health effects. And risk, the probability and degree of possible injury when exposed to that hazard, comprised of 3 factors: severity, frequency, and possibility of avoidance. So for example, if you have a small part on a children's toy, the hazard itself, the hazard would be the small part on that toy. The risk would be the possibility that a child will choke on that small part. So if you have no hazards, you have no risks. So why do we assess risks? Possible risks must be analyzed, and where necessary, additional protective measures must be taken to protect the operator from any hazards that may exist. We have to do this whenever we have a new design. So if we're talking about a piece of automation or equipment in a factory, anytime this is a new piece of equipment, if it's refurbished, rebuilt, or redeployed, we must evaluate, assess, and try to reduce the risks that are there. There's no specific outlines for this, but there are standards that do exist. When we talk about risk assessment, there's a couple things we need to talk about. First of all, the task analysis, actually looking at what the person in the area that is affected will be doing, that person that's exposed to these hazards. Are they loading or unloading? Are they doing startup? Are they doing operation of the machine? Are they doing unjamming? Are they doing teaching of a machine, like teaching a robot? Are they doing troubleshooting? These are all different questions we need to ask. What is the person actually trying to accomplish? Because that influences when we look at what is the possibility for avoidance, what is the frequency that they're going to be in contact with these hazards. These are all things that come into play there. Other things that will come into play as well, the machine limits. So these would be things like the production rate or cycle time of the machine, speed of the machine, how fast does the thing actually move, forces that are involved, materials that are involved, the number of people working in an area, temperatures that are involved, things like that. We're talking about thermal hazards, temperatures are important. These are all things we need to consider when we're actually talking about risks and hazards to do a proper risk assessment. So to do a risk assessment, we basically look at a chart that's laid out kind of like this. So we have our starting point up here, and then we're basically going to, first of all, look at defining what the limits are of the machine, so gathering up all that information we just talked about in the previous slide. We're going to identify what the tasks are that are being done. We're going to identify all the hazards that are involved. And then we are going to estimate what the risk is for each of these hazards. We'll talk about that in a second. And then we need to evaluate what level these hazards, these risks present. And then we need to come up with some different methods of reducing those risks. Now after we do that, risk reduction, we're going to ask ourselves, have we done a good enough job to reduce the risks that are involved? So we're going to put in some measures to reduce those risks. If we have reduced them to a reasonable level, and what we call a reasonable level is kind of fuzzy, we need to determine what is a reasonable level of risk, and then what is acceptable, and then have we done enough to reduce that level of risk. If the answer is yes, then we are done. If the answer is no, then we basically need to go back and reevaluate. So now that we've put in some measures, let's look at this again, reevaluate, and look at what other measures can we put in. We keep on going like this in this process until we get to a point where we say, yes, we have reduced all the risks that we can to a reasonable level. This is our risk assessment process. The risk estimation chart looks like this. So when we determine a risk, we talked about severity of injury, exposure, and chance of avoidance. We use this chart to determine what level of risk we end up at, and then this will also recommend a method of risk reduction for us. So for example, we're going to start over here, and we're going to determine first off, is the severity of injury from this hazard and risk, is it serious or slight? And then depending on which way we go, here, we'll determine next the frequency of exposure to that hazard. Is it frequent or infrequent? And based on that decision, we'll then finally determine what is your chance of avoidance of that. And we'll talk a little bit about what these definitions actually mean later. And then we'll say, is it likely to be avoided or is it unlikely to be avoided? And then that is going to put us somewhere on this chart, on this scale. Over here, down at the bottom, we have a low risk hazard. At the top, we have a high risk hazard. And somewhere in the middle here, it's going to recommend a method. And there's basically 5 different methods that we're going to look at. 5 different methods of risk reduction. And this will recommend what the optimal one that we should aim for. So basically it's a 3-step method. We want to basically, if we're designing a system, we want to try to implement a safe design. We want to eliminate or minimize as many risks as we can in the design process. Then when we actually go to build this machine, if it's a machine we're talking about, there are some risks that we can't design away. We'll have to put steps in place. We're going to call these engineering controls that will guard against the risks that still present themselves. And then beyond that, we'll have administrative measures to inform and warn about the residual risks that still exist beyond what we could design out or protect through engineering controls. There's our chart again. So let's talk about different methods of risk reduction. So the very first one we're going to talk about is called elimination and substitution. So this is our highest level of risk reduction methods. Elimination and substitution. So some examples of these. Basically, we're going to talk about completely eliminating, first of all here, eliminating human interaction in the process. So an example of that, if we have a process where boxes are being loaded by humans and there's a hazard of boxes tipping over or just other things going on with that process, what if we replace humans with robots? Robots don't get hurt like humans can. So completely eliminating humans out of that process, replacing them with a robot or a piece of automation, that would be an example of elimination or substitution. We talked about that with automated material handling and elimination of pinch points. This little example over here, if we look at this drawing here, you can see here if we have this guy, this moves up and down. You can get your finger caught in here. That is a pinch point. So if we can eliminate that pinch point, like for example, if we can just add this little piece right here, if we can add this in here, then it's impossible to get your finger stuck in there. Okay, so that is just an elimination through design, just designing out and eliminating a possible pinch point. Okay, so these would all be examples of elimination or substitution. Second one we're going to talk about here, engineering controls. So these would be things like putting in mechanical hard stops, so to limit the motion of something, putting in barriers like fences, so putting a perimeter fence around a robot cell so people can't get into a robot work area, using electrical interlocks, so things like a switch that will disable the system if a door is opened. That would be something like that. Using two-hand controls. This here is a two-hand control system. What happens there is in order to start a process, someone actually needs to place both hands on those buttons at the same time. If they only put one hand on, it won't start. So we know that if they're putting both hands on there, that's the required method to start this. If both of their hands are there, we know that one hand is not in the machine. Okay, so that is two-hand control. We also have things like barrier protection, like these light curtains over here. So these light curtains that basically detects if you put your hand or any part of your body through an opening, it will shut a machine down. So these would all be examples of engineering controls. Awareness means this is things like using signage, using lights, using lines on the floor, things like that. Anything like that that basically gives you a visual or audio indication that there is a hazard present. Okay, this would be called awareness means. And this is a completely valid form of risk reduction as well. This is a code here that shows typical codes for lights, what they mean. Red meaning danger, yellow meaning warning, green meaning safe. Pretty straightforward. This one here, training and procedures. We call this this is being an administrative control. So basically doing training, having proper training on what those risks and hazards are. So training such as lockout training, just general training, safety equipment inspection, or safe job procedures. Having all these processes in place at an administrative level can be a way to reduce risks as well. And the final one here, personal protective equipment, or as we will call it, PPE. Things like safety glasses, earplugs, face shields, gloves. Basically the final line of defense, actually physically protecting the person from by making them wear something that protects them from a hazard. So when we look at these things, those are our 5 methods of risk reduction. The elimination and substitution, that is the most effective. Personal protective equipment is the least effective. Okay? So that is the ranking system we would want to give these. If we can eliminate or substitute a hazard, that is the best way to go. The least effective way we can go is just to put safety glasses and safety shoes and gloves on a person and say the hazard's still there, you're going to protect yourself this way. Okay? So one thing to remember here, all these definitions are very fuzzy. There is no one single simple way to determine the level of risk, nor will a single technique apply to all situations. The organization has to determine which technique will work best for each situation. Ranking hazards requires knowledge of the workplace activities, urgency of situations, most importantly, objective judgment. For simple or less complex situations, an assessment can literally be a discussion and brainstorming session based on knowledge and experience. In some cases, checklists and probability matrix can be helpful. For most complex situations, a team of knowledgeable personnel who are familiar with the work is usually necessary. Okay, there's a lot of words there, but basically this is saying there is no one set tried and true method of doing this. This website here, it gives some good guidelines, but a lot of the definitions for this are not set in stone. Okay, so when we talked about severity or seriousness, exposure, and avoidance. What do those scales actually mean? When we say a serious injury versus a slight injury, think of this as a sliding scale. You need to pick one of these options. Let's talk about seriousness. When we talk about serious, we're talking about a fatality. Okay, that's what we'll call serious on one end, And then a slight injury, we'll talk first aid. Like you cut your finger, you need to put a band-aid on it. That would be slight. So if you're talking about anything like a broken bone, you need to pick which way am I going on that. Am I calling that serious or am I calling that slight? Okay, you'll need to make that determination. For our purposes, like when we're asking questions and doing testing and things, as long as you can justify your answer, we will call that correct. Exposure, the frequency of exposure, we're calling this frequent or infrequent. When we say frequent, we're talking about in the case of a machine, if you are required to do something every few seconds or every part. So for example, if you are running a punch press and you need to reach in and grab and pull a part out every single time that press hits, that would be frequent. Okay? If we are talking about infrequent, would be a maintenance function. Maybe this is something you're doing once a week. You need to go in and maintain something once a week. We would call that infrequent. And then likeliness of avoidance. Unlikely versus likely. If something moves really fast and is very quiet, so for example, a robot will move very quickly and you don't hear it. If you're in the way of a robot, it is very likely to hit you. It is very unlikely that you're capable of avoiding that. If something moves very slowly and it's very loud, your chance of, for example, if there's a big door that opens and closes and moves slowly and you can definitely hear it moving, you have a good chance of avoiding that. We would call that likely chance of avoiding. Also, another thing, if you were having something like, let's say there's a saw blade or something like that and you have to pull parts out from around that, and if you have to reach in very close to the blade every time, like within 2 inches or so, it is unlikely, we'll call that unlikely, that you can avoid. If you have to reach in but you have 18 inches of space between where you have to reach and where the hazard is, the chances of you being able to avoid that, we're going to call that likely in that case. So the difference there between if there's good spacing, not good spacing, that could affect likely versus unlikely as well. And once again, as long as you can justify all these choices, that's good. It's like we said before, risk reduction, not exact science. We're trying to establish decision-making guides to help achieve a reasonable outcome. So we have an interesting situation this year. So let's with COVID-19 and risk assessment. So let's think about some things now and step out of the machine world for a minute, and let's look at the COVID-19 world. So this has caused many institutions and workplaces to perform risk assessments. Theories behind these basically the same as evaluating a machine or a process being evaluated in a factory. So this has been done a lot at the college this year. So let's think about some risk assessment situations involving COVID-19. So for example, with COVID, what is the hazard that is present there? So let's think about that for a second. So I would say with COVID, the hazard is, let's call it the COVID-19 virus. Okay? That would be the hazard that is present. What is the risk with COVID-19? We're going to say risk of contracting. From close exposure to infected people indoors at indoors at close distance or shared contact. Let's call it that. Okay? So that would be our risk. So let's evaluate this on this chart. So let's say we're going to start. Let's start over here. Severity of injury from COVID. Serious or slight. We're going to say the potential for injury. Well, let's call this serious. Okay? Possibly fatal. Okay? I mean, there's a huge range on this, but we'll say potentially fatal. Okay? So that immediately puts us on this upper branch. So the best case scenario we're going to have is we are up here. Let's talk about the exposure. So let's talk about the situation we're talking about here is, we're just going to call this being on campus. Being on campus, we're going to call this normal. So just if it was a normal term, you're on campus, what are the chances of this? Exposure. So if you're on campus and there's thousands of other students there walking around, being in the same spaces together and things like that, I'm going to say the exposure chance frequent. You're going to be in close contact with 1,000 other students a day, maybe 5,000 other students a day. That is I think statistically that is a frequent exposure. You're going to be frequently exposed to potential hazard. And then the possibility of avoidance. We're talking about breathing. So I'm going to say possibility of avoidance, not likely. So this puts us up here at basically the highest risk category. So what it recommends here, hazard elimination or substitution. Okay, so basically it's recommending go to the highest possible level of risk reduction. Okay, so this is how we would use that chart. So, and ask a bunch of questions here. What is an example of elimination or substitution that St. Clair College has implemented to reduce the risk of COVID-19 to students? So think about that for a second. Now, I think there's one very obvious one that we are doing right now. Online classes. Okay, now, and this is where you get into risk reduction versus complete elimination of risk. If we wanted to completely eliminate all risk, that's basically back when we were in lockdown. We basically said we're just not going to have any classes at all. Okay, we are trying to basically reduce the risk down to what we consider to be a reasonable level, so that we can continue on at a reasonable level of risk. Okay, so what we have here, we have online classes, and what that enables us to do, that reduces that is basically attacking so this one here, nothing we can do about that. There's nothing we can implement that changes the severity of injury. What we can do, we can try to reduce your chance of avoidance. We can try that one, and we can try to change your exposure from frequent to infrequent. So by going to online classes, you've definitely changed the chance of exposure from frequent to infrequent, because this has drastically reduced the number of people you're actually in contact with in the course of a school day. Okay, so you have basically one lab on campus now. You're exposed to maybe 30 people altogether in your course of going to and from. And then we are also implementing our social distancing practices while you're there as well. So your direct contact with people dramatically less than normally. Let's think of an example of engineering controls that have been put in. So think about the way this has been done on a machine, and then what is an example of anything COVID related that would be an engineering control. So the one I can think of right away I'm sure this exists on campus. Let's talk about barriers. So on campus, there's only certain doors you're allowed in. So they are limiting access to the college. So you can only go in through certain doors. That's basically creating a perimeter of controlled access. Another case here, lots of plexiglass screens around if you go to buy something. And you see this in a lot of stores now too, where there's basically a piece of plexiglass between you and the cashier. So that's creating a barrier between two people. Okay? So good examples there of engineering controls. Awareness means. What would be some good awareness means? So different signage and things like that. So let's think about that. You may have seen different things like this where they put the big circles on the floor, say stand here, stand here, stand here, to remind people of social distancing. That could be one. There's signs everywhere now. And this is all basically things to make you aware visually, to tell you, to remind you to keep your distancing and things like that. Okay, so those would all be different awareness means. Training and procedures. What would be an example there? How about everybody had to complete COVID-19 training on Blackboard before they could go on campus? You also have to do your your training, and you have to do your screening as well. Okay. So let's call that online training. And obvious one here, example of PPE. I'm sure everyone loves this. Everyone has to wear their mask all the time. Okay? That would be an example of PPE. Okay, so there's hitting all 5 of those, all different examples. So let's say if you're implementing all of those different policies, what can we do here? So let's start from here. We are still serious, but now we've been able to reduce this down probably to infrequent, and we probably can reduce down your chance of avoidance. Can probably drop down to likely to avoid as opposed to not likely. And that drops us down to somewhere in here. Originally we were up here, we dropped it down to here, and that's as good as we can do for something that's a serious injury. Okay? So that is using a whole combination of these different methods to try to reduce the risk as much as we can and to get it down to as much as we can to get it down to what we're calling a reasonable level. Okay, let's take a little break right there.